All right, today we're going to dive into a really powerful design pattern, one that can take some of your messiest code and turn it into something clean, flexible, and, well, just better. It's called the chain of responsibility. You know the drill, right? If you've ever written any amount of code, you've been here. It starts off innocently enough, just one simple if statement. But then you need another, and pretty soon you're staring at this massive, tangled web of conditions that's a total nightmare to read, let alone try to change later on. It's just so rigid. But what if I told you there's a much cleaner way to do this? A design that lets you break all that logic up into these individual, separate pieces. I mean, imagine different objects each getting a shot at handling a task without the original sender even knowing or caring who actually does the work. So let's talk about this better way. The solution is actually pretty elegant. Instead of having one massive object trying to handle everything, we create a chain of objects. Think of it like a line of specialists, where each one is a potential handler for a request. So at its absolute core, this pattern is all about one thing: decoupling. The object that kicks off a request, it doesn't need to know which specific object is going to process it. It just fires the request into this chain of potential receivers, and the very first one in line that knows what to do with it, well, it handles it. Simple as that. Okay, that might sound a little abstract, so let's make it super concrete. Let's step away from the code for a second and think about something we all get: a visit to the doctor's office. So you, the patient, you're the request. The first object you hit in the chain is the receptionist. Their job is super specific. Check your eligibility, your paperwork, if everything checks out. They don't solve your medical problem, right? They pass the request, you, to the next link in the chain, the nurse. The nurse handles their specific task, taking your vitals, and then passes you along to the final handler, the doctor, who finally gives the diagnosis. See? Each handler does its one little part and just passes the request on. And this whole process leads to one of two very simple outcomes. Either some handler somewhere on that chain processes the request, or the request makes it all the way to the very end of the chain, completely unhandled. And that second possibility, that is a really critical detail that you have to remember. Now, this pattern isn't just some academic idea. It's actually running under the hood in software you probably use every single day. So let's look at a few examples of the chain out in the wild. A perfect example is your email's spam filter. An incoming email, that's the request. The first handler in the chain might check it against a block list. If the sender's okay, it passes the email to the next handler, which scans the content for spammy keywords. If it's still clean, maybe another one checks for suspicious links. The very first handler to flag it as spam just stops the whole chain right there. The same thing happens in user interfaces, where a click event might get handled by a button or get passed up the chain to a bigger container panel. But, like any design pattern, this is not a silver bullet. It has some seriously powerful advantages, but it also comes with some important trade-offs you absolutely need to think about. I mean, the advantages are really compelling. First, you get that beautiful decoupling we've been talking about. Second, the chain itself is incredibly flexible. You can add new handlers, get rid of old ones, or even shuffle their order around at runtime without breaking anything. And this is just a brilliant example of the single responsibility principle. Each handler has exactly one job, which makes your code so much cleaner and easier to test. But all that flexibility comes with a price. Trying to trace a request as it bounces through a dynamic chain, that can be really tricky to debug. And if your chain gets too long, it can start to impact performance. And most importantly, you have that critical risk we talked about. What happens if no one in the chain can actually process the request? Seriously, let this one sink in, because it's probably the single biggest warning label on the chain of responsibility pattern. Unlike a switch statement or an if-else block where you almost always have a default case, a request sent down a chain might just fall right off the end, totally ignored. So what do we do about this? Well, it means you, as the architect of the system, you have to make a very conscious decision. Is it okay for some requests to just go unhandled? Or do you need to make sure you have a default handler sitting at the very end of the chain, ready to catch anything and everything that gets through? And that really brings us to the final takeaway here. The chain of responsibility gives you this incredible, flexible way to escape those nested if-else nightmares. But its real power depends entirely on how you design it. Will you build your chain for maximum efficiency, or will you guarantee that every single request is handled by adding that final catch-all?
That's the design challenge. And now you've got a new pattern in your toolkit to help you solve it.